Hey guys, and welcome to lesson 8B, Simplifying Radical Expressions. Just to let you guys know, this is one of my favorite lessons in the history of Algebra 2. So you're going to have to deal with my extreme enthusiasm about the topic. But we're going to start off with two different properties, the product and quotient properties of radicals. Basically, the nth root of any number, a times b, is equal to the nth root of a times the nth root of b. It just allows us to simplify our radicals. So if I have the square root of 5 times the square root of 6, that's the same thing as the square root of 5 times 6, which is the square root of 30. Okay, and my handwriting's messy. Sorry, folks. So similarly here, the cube root, we call that the cube root because there's a 3 there. The cube root of 2 times the cube root of x is equal to the cube root of 2x, and nothing can come out. Come down here, the cube root of 2 and the cube root of 4 is equal to the cube root of 8. Well, friends, 8 is 2 times 2 times 2. So if we're taking the cube root of that, that means we're just going to get 2 because the cube root tells us it takes 3 of one like thing to break one out. So that's not too bad. Here, the cube root of 5 times the square root of 4. These cannot combine because they're not like terms. But the square root of 4 we know is 2, so we can do 2 cube root 5. I want you guys now to try this one on your own. Go ahead, pause the video, give it a shot. Okay, go ahead and check your work. If we've got a fraction, same thing applies. We simply multiply my tops together, 5t, and multiply the bottoms, 2m. All right, let's look at our next page. All right, now we're going to use the quotient rule to fully simplify. Well, 25 over 49 itself doesn't simplify, but if we recall, 25 is 5 squared, and 49 is 7 squared. Well, the square root of 5 squared is 5, and the square root of 7 squared is 7, so we just get 5 sevenths. Whereas here, I can't simplify the top. The square root of x just has to hang out. But the square root of 9 is 3, so he's good to go. Here, the fourth root of 3, he can't simplify. He has to stay. But if you recall, 16 is the same thing as 2 to the 4th, so I really have now, why is the pen behaving like this? I really have 2 to the 4th, y to the 4th, and the 4th root of those. So I get the 4th root of 3 over 2y. And I want you guys now to try these two. Pause your video, take a look at it, answer the questions. Okay, go ahead and check your answers. 2/3 and the square root of z over 4. All right, let's take a look at these. You need to know these powers, right? Off the top of your head, be able to spit them out, no questions asked. Basically, your perfect squares through 12, your perfect cubes through 5, your perfect fourth powers to 4, and 2 to the 5th. You've got to know these really fast because they're going to show up all the time, and we may not let you use a calculator because we expect you to be able to do these, especially the perfect squares, guys. We learned those in 4th grade, or maybe even 3rd grade. We should be able to do those. Anyway, moving right along. Let's talk about how to simplify the radical expression. A radical of the form the nth root of a is simplified when the radicand a contains no factors that are perfect nth powers. So when I look at this, my first step is always to break down whatever I have down to its basic, like to expand it out. Use a factor tree, use the wedding cake method. I know Miss Kidder loves that method. Whatever method you need, use that to get these down to their fully factored form. So let's take a look. If I've got 162 into the 9th, the first thing I'm going to do is I'm going to factor tree 162. I factor treed my 162. I got 2 times 3 times 3 times 3 times 3. So when I look at my fourth root, I'm going to write those out as factors. 2 times 3 times 3 times 3 times 3. I've got 9 ends. This is kind of painful. 1, 2, 3, 4, 5, 6, 7, 8, 9. That better be 9. Yep, 9 ends. And what this fourth root means, that it takes 4 of something inside the radicand to break one thing out of the radicand. So the 2 gets stuck. But look at this. I've got 4 3s, so a 3 can come out. Here I've got a set of 4 ends. 1 end can come out, a second set of 4 ends, another end can come out, but there's a lonely end left inside. So I can take out a 3 n squared, and inside my fourth root, we still have 2n. Now, do you have to write out that long string every single time you do a problem? Oh, please no, don't. If you can see it, do it. Like, I asked myself, how many times does 4 divide into 9? It divides in 2 times. That's my square. How many are left over? 1. That's how many is left inside. So let's take a look at the 125x cubed. Well, I know 125 is really 5 to the third. That's 5 times 5 times 5. And x cubed is x times x times x. This is a square root. We never have to write the 2, so pairs break out. I can take out a 5, I can take out an x. So my answer here would be 5x, and then what's left over is another 5x. So 5x square root of 5x. So C, here I look at this, I've got a 54, x to the 6th, y to the 8th. Well, I know that 54 is, let's factor tree it. Basically, it's 2 times 27, or 2 times 3 times 3 times 3. So now I have the cube root of, ready? 2 times 3 times 3 times 3, x to the 6th, y to the 8th. Well, the 3's break out, the 2's don't, so I can pull out a 3, or I can pull out a 3. X to the 6th divided by 3. Well, 3 goes into x to the 6th twice with nothing left over, so a full x squared can come out. And 3 goes into 8 2 times, so another y squared can come out, but there's some left over this time. So that 2 stays inside my radicand. And if 3 times 2 is 6, so 6 of these y's broke out, which leaves 2 of them left over inside. So that's how I decide what stays inside my radicand. And so that's my answer right there. 3x squared y squared times the cube root of 2y squared. I know that's a mouthful, but. Okay, I want you guys now to do D and E and then check your answers. Okay, guys, go ahead and check your work. Oh, there should be a 3 there. Sorry. Don't forget your radicands. All right. So now we're going to use the quotient rule to divide and then simplify. Now, if you recall, square root over square root is the same thing as the square root of 20 divided by 5, which, by the way, guys, 20 divided by 5, as we all know, is 4. Well, square root of 4 is 2. We like that problem. Very easy. Here, I am actually going to simplify the top first, I think. Well, the square root of 50x, well, 50 is 25 times 2, and we still have an x, over 2 root 2, which means that here, a 5 can pop out of this, but I'm left with the square root of 2, and I make that times the square root of x for a reason you'll see here, over 2 square root 2. Well, the reason I did that is those can cancel, so I'm left with 5 root x over 2. Oh, and that's a hideous one. Let's take a look at it. 7 times the cube root of 48 x to the 4th, y to the 8th, over the cube root of 6y squared. Well, this time I'm going to leave the 7 outside, and I'm just going to look at the 2 radicals. And I'm going to put them under one radical here. 48 x to the 4th, y to the 8th, over 6y squared, and all of that's the cube root. Well, 48 over 6 can simplify. So we still have the 7 out front. 48 over 6 can simplify. to 8. X to the 4th has nothing to compete with, so he's still x to the 4th. And then y to the 8th over y squared gets me y to the 6th. Remember, if we have exponents, we can subtract the exponents if we're dividing. And now we just have to take the cube root of this thing. Well, we still have the 7, and the cube root of 8 is 2, right? Because 2 times 2 times 2 is 8. The cube root of x to the 4th is just going to get me x, and there's an x left over that I don't see yet. And the cube root of y to the 6th is going to be y cubed. So what was left over? Just one of the x's. Okay, and I'm going to simplify this a little bit, which gets me 14xy cubed times the square root of x, and that is my final answer. All right, guys, I want y'all to do these three and take a look at it, and then check your answers. All right, check your answers, and we'll go over these in class. Okay, let's talk about adding and subtracting radicands. If you recall from really pre-algebra, we can only add like terms. So 2x plus 3x we can add because they're like, they make 5x. Similarly, 2x plus 3y we can't add, so they just end up as 2x plus 3y. That's as simple as that gets. We learned in Algebra 1 that we can only combine like terms. Well, we can also only combine like radicals. And like radicals have to have the same index and the same radicand. So for example, let's try this. 2 square root x and 0.6 square root x, these guys are like because they have the same radical and the same thing inside the radical, but 2 square root 3 and 2 cube root 3 are not like because they have a different index. This is the index in the radical. And similarly, 2 square root 3 and 2 square root 4 are not like because they have different numbers inside the radicand. So 2 root 5 and 3 root 5, these are like because they have the same index and the same radicand. So we add them and we just add the first numbers. So 2 plus 3 gets me 5, and then the index tags on, or the radicals tags on, square root 5. So let's keep looking right here. 2 root 6 plus 5 root 6, those are like terms, so I get 7 square root 6. 3 square root 10x minus 4 square root 10x minus 5 square root 10x, those are all like because they all have the same number here, square root of 10x. 3 minus 4 is -1, minus 5 is -6 square root of 10x. Whereas this guy, 5 root 2 plus 7 cube root 2 minus 3 cube root 2, these guys are like, but this guy is not. So he just chills out at the front of the problem, while these guys actually combine. 7 minus 3 is 4 cube root of 2. So before we try to simplify our radicals, we have to always check to make sure that our radicals are already in simplest form. So here, the square root of 20 is really 4 times 5, so 2 root 5, minus, here, 45 is really 9 times 5, which that pops out of 3, so I get 3 root 5. So here, 2 root 5 minus 3 root 5 equals negative root 5, negative 1 root 5. And again, when we first looked at it, it didn't look like that it had like radicals, but when I simplify it, they became like radicals. So let's now take a look at B. 3 root 18 minus 6 root 50. Well, the 18 is 2 times 9, so I can pull out a 3, making that 9 root 2, minus a 5 can pop out here, making this 30 root 2. 9 minus 30 gets you negative 21 root 2. And so on and so forth. So I want you guys now to try these last 4 problems. I know it says only to try the last 2. I want you to try the last 4, and we'll go over them in class. Thank you guys so much. go ahead and check your answers. Thank you guys so much.